In this episode, I will show you how I powered my DCC layout. Stick around. Hi, and welcome to a new episode. Today I would like to show you what powers my layout. Some may think it's overcomplicated, but I like it. I'm happy with it. Not the neatest, I must admit, but hey, I know what there is, I know where each wire goes, and that's what's important for me, that I know where they go. I may not have any labels anywhere. You might see a few joints too many. Example, this kind of thing here. That was an ongoing project, and I abandoned it, and one day I'll get around to cleaning that up, all in good time. Anyway, I run my trains using the Z21 in the back there. It's a Z21 start here, that white box there, and it does not have an output for a programming track, just the main line. In the beginning, when I wanted to do some programming, I used to remove all the trains of the layout just to program one train. Eventually, I isolated the whole layout except one of the blocks, and I used that as a programming track. But times changed, and we evolve, and we have new ideas, and we move on. I learned, I've said this a few times, I want to repeat it. I've learned not to handle my trains. One, they are so small and fragile that to break one of the railings or a buffer, it's very easy, especially me being a bit clumsy when they're in my hand. And the other is if I have to slide them back, because I was running them manually, and I went into a closed point and I shorted the line at the frog end. I would need to slide the train back to clear the short, reset the Z21, and that's it, and off I go. But when I did that, not too many times, but a few times, and sometimes a few times too many, again, I had to handle them. I derailed them because it was around the bend, and I pushed and they derailed. And most of you that know my layout, I don't have many long straights, and I like to run long trains, and when that happens, 9 times out of 10, part of the train is in a curve. So when I push, something gives, and the trains derail, and then it's a bigger hassle all over. Plus, I have to manually handle the trains and the wagons, which, rule number 1, I don't do. So in time, I stopped using the Z21 to operate my accessories. And when I say accessories, I mean my points, my lighting, anything motorized or animated. I use the Z21 solely for running the trains. That's what they do. The Z21 powers the motors on the locomotives and nothing else. The rest on the layout, whatever you see, is operated using an Arduino. So I started with an Arduino. Hang on a minute, let me slide this over here. Here. With this Arduino here. This is a Mega. I have a network card and not Wi-Fi on it, and I have a motor driver. But with the number of accessories that I have, I soon ran out of memory on the Mega, and it was either disabled the network card to gain more memory. It was becoming a bit of a pain to do any changes to it. I would have to disable one thing and then enable the network card. It was becoming a pain. Luckily, I learned that, let me move it back, that DCCX running on ESP32 also works, besides DCCX running on the Mega 2560. And it has a lot, and I mean a lot more memory. But the downside is, because I don't know how to do it, and when it was explained to me, I pulled away because it was a bit too advanced for me. I cannot run the trains on it. Now you would tell me, why would you want to run the trains on that when you have the Z21 doing all that? Because I was using the original Arduino setup, that is the Mega 2560 with the motor driver. I was using that just to run the programming track, so I could address I could program loco while the trains were running, because the Arduino was addressing a programming track which is up here where these wagons are at the moment, and it's completely isolated from the layout. So I could address the programming track from my phone, I could address it from Decoder Pro on my PC while the trains were running, and one did not interfere with the other. And I was very happy with that. But when I went over to the ESP32, which handles all my accessories with all the animated doors on my buildings, those who have seen them know what I'm talking about. If not, have a look at my channel and you'll see a few animated doors. But I cannot use it for a programming track. So instead of throwing out the old Arduino running the DCCX with the motor driver, I kept it just to power the programming track. So now I have the Z21 start to run the trains. I have the ESP32 here controlling all the accessories. So that is for the main layout. Any programming I need to do, let me come back here. Any programming I need to do, I connect to this by means of, like I said, a tablet, my phone, my PC, via USB or a network card here. And I do all the programming I want while the trains are running. Like I said again, nothing interferes from one system to another. They're completely disconnected from each other. And with that I have learned it is so much easier and safer, because I handle the trains a lot less. So, in case you are wondering what all these power supplies are, this is a 9 volt to power, a 9 volt DC power supply to power the Mega 2560. This is a 15 volt and it's lowered down to 12, powering the motor driver. That will power the programming track. The ones in the back, the one, hang on a minute, there, the one on the right, this one here, that's powering the Z21. I had originally removed the power supply that came with it. I had this running here, sorry, to charge my lithium polymer or LiPo batteries here for my remote control cars. And it was, I think it's a 15 or 16 volt, 16 volt power supply. And once it's there, I plugged the Z21 in it, and it's doing just fine. In fact, it's powerful enough to run the Z21 and charge 2 batteries with 2 chargers at the same time. And the Z21 goes on like nothing ever changed that. Let me move this slot here now, and move Hang on a minute. I've got a knot here with camera stands and lighting. Okay, the ones in the back. The one on the left is a 5-volt power supply. This one is powering the PCA 9685 boards, which I have throughout the layout. I think I have nine of them. It's a 5 amp power supply. Ideally, it is recommended you use 2 amps per board, but I mean, I rarely ever use more than one board at the same time. I rarely ever address more than one at the same time, and I mean, I've been doing this for over a year now, and they seem to be working just fine with 5 amps. The middle one is a 12 volt that was powering the DigiKeys 4024 servo controllers, which over the years I removed and replaced with the Arduino setup. So it's sitting there doing nothing at the moment. And the one on the right is another 5 volt, which powers the DigiKeys opto sensors that I have in some of the blocks. Now I will take you over to the other panel and I'll show you what I have there. These are my current sensors. I use the DigiKeys 4088 with RBus, obviously, because that is the only protocol the Z21 start supports. I have had no problems at all with them, to be honest with you. I find them very good. Pity I can't find more, because I would like to buy 1 or 2 more. I have 16 different blocks on all 4 here. I think I have one free somewhere. Here, I have a free one here. And then I have this lot here. Let me show you, let me turn here. This is the opto sensor. This is for the infrared sensors, which I use under the track for block detection in areas where I had this, I don't have any more ports, and I use that instead. I use relays for that, and I latch the relay on the train's way into the block, and on exit it finds another infrared sensor which releases the relay, and that way the software, which is iTrain in this case, it releases the block and moves on to the next. So these are connected with RBus here. This is moved all the way to this one, RBus as well, and these are all linked here through Ep81 connection, just like that, very simple. They are all powered through the same DCC supply that is coming from the track. Oh, sorry, except this is a 5 volt in here, and the 5 volt here is detected from the activity on the infrared sensors. This is my manual control when I want to move them about manually. I rarely do it, but I find this very good when I have an issue, like I want to put my head down very close to a point. I don't need to use the PC. I just move the trains back and forth to find where the fault is. And since it's wireless, I mean, I can go about anywhere with it here. This is the display of my PC. What you are seeing here is iTrain, and at the moment it's active. The red sidings here, or tracks or blocks with the highlighted red current sensor, is where there is either a loco parked there or an active train. If it's parked just sitting there, the neighboring blocks are grey because there is no activity. While, for example, in this case here, the train is coming up from the fiddle yard here, and where you can see orange, it's where the train has reserved the following blocks So you can tell that that train is in motion. Like this one just changed here because the train is coming from here and reserved the next block here. That's what iTrain does when you're running in automated mode. Here you can see a couple of trains going by. Hang on a minute. I don't know if this is a good angle, but there's one DMU going by. And the other one should go when it's released. Yes, it's been released and it's moving. Okay. Okay. Just one last shot left. I want to show you my PC. My PC, as you can see, is not in a case. I had an old XD case before, a micro SD or a mini SD. I forgot XD. I forgot what they called them. They're so old. Anyway, and obviously today's motherboards, well, at least the ones I chose, it's a gaming board. It's a bit larger than the case, and obviously it's not going to fit in the case. Plus, it fits perfect in the shelf I had for the old PC, which is hung here. This is hung under the baseboard. It's out of the way, doesn't take any space up, it's well ventilated, and I'm happy with that. This is the old hard disk from the other PC. I started with this on the new PC, but it's at the end of its life, and now this PC is running a solid state drive plugged on board directly, and it's one hell of a fast PC, even if I say so myself. Okay, and let's see what next. And last but not least, this is about programming here. Like I said, I have the programming track up here. Hang on, let me do this so you can see it better. That's my programming track there, with the derailleur in place permanently. So when I want to use the programming track, I would put this on track. Now, if I'm doing programming through the Arduino, I would put the switch up top, and when I'm using the ESU controller, I would put the switch here. I have an ESU controller there, programmer, actually not the controller, sorry, the programmer, it's here. I find that good because I have many ESU decoders, and they like to update their firmware from time to time. So that's what I do. Now, if I want to program a card, a decoder, I use this. I just plug in, let me find an easy one. I just plug in this case it's an X18 decoder. I have a 6-pin decoder, it fits here, and various others, but I only use these two on my, and sometimes here when they're the wired ones, like when I'm doing a conversion from an old DC engine to DCC. Anyway, these colors here, just for me to realize that the motor is actually spinning, because when it's all bronze, you don't see it moving much. Anyway, and I select here for track or card, which is this here. I leave it off in the middle and same there. The plugs here, the red is disconnected, as you can see. Whatever selection I have here, these will have the same thing. This is always on, that's why it's disconnected. And these pair of wires here go to my workbench. I have a track there, and sometimes while I'm working on an engine and it's in pieces and I want to power it up to try out whatever I'm doing, instead of coming all the way here, I just use the little track there, and I use my phone most probably, because that's the only access I have from that location there. So, and this hole, finally, this hole here will be, well, I'm putting this in there, obviously the other way around from the back. It's going to be an double pole, double throw switch to select the current programming track or one of the blocks I have designated on the layout to become powered by the Arduino. The reason behind this is very simple. Let me position the camera and I will explain. This is from here. This is the block I want to use as a programming track up to that point. On iTrain you have to set up every locomotive and you have to run them through a speed measurement process, it's called, and that way they will all run at the correct speed with each other, and you won't have one running faster than the other. If you put a limit of, say, 40 kilometers an hour, they will all run at the same speed. Plus, you can get them to stop in the same place wherever on the layout. You don't have to make changes for each engine on the block. If you set a stop positions, for example, 30 centimeters from the end of the block, they will all stop there if you do your speed measurement correctly. So, to do the speed measurement, you need one block, in my case, two blocks up to this point, and three blocks. So the let's put some oil there. The engine starts there on this part here. When I set the test off, it zooms down here, all the way here to there and back. And when it comes back, I adjust the values of the CVs. That would mean picking it up, putting it here, adjusting, picking it up again, putting it there. And rule number one is don't touch the locos. So I've been thinking about this. So I said, I'll make this a switchable programming track. So when I want to do speed measurement, I get the train to come up here. I switch over, I flip over the switch for this to become a programming track. I set the CV that I want for that particular engine, okay, and then run it down the line. And once I do that, and it comes back, and if I need the adjustment, I flip the switch again, change this below track here to a programming track, do what I need to do, flip it over to the main line, and we're done. That is all I have for you today. Hope it clears up some of the questions you may have had. I would love to answer any questions you have, and hope you enjoyed this video. This one's coming in. It's going into the siding there, coming up. Well, let me just see it stop. Basically, this is the speed I like running them at. Maybe a bit faster. But this one's coming into stop, so it slows down here. It's coming in for stopping. End of the line. Come on. And that's it. So, until the next time, guys. Take care.